Welcome back. In this video, we are going to solve a structural design problem that involves a two-way slab design using the working stress method based on eStructural Design Taichi, found on the App Store. Design a reinforced concrete two-way slab using working stress method for residential use, with clear span of 20 feet by 20 feet and assumed thickness of 5 inches. Design criteria as follow. Strength of concrete is 3000 psi. Main bars half-inch diameter bar grade 33. Case number 4 for panel design. The first step in slab design is to determine the total load. In this example, we assumed a slab thickness of 5 inches which translates to 62 pounds per foot, a residential live load of 40 pounds per foot, and additional 40 pounds per foot dead loads for floor finish and partition, which gives us a total uniform load of 142 pounds per foot. We use Case 4 panel configuration in our design. Enumerate all input parameters in our design problem. S2 for name of slab. Case 4 panel design. Longer span of 20 feet, shorter span of also 20 feet. 5 inches slab thickness. Half-inch diameter bar, grade 33 main bars. Strength of concrete is 3000 psi, and a total load of 142 psf. Solve the balance section properties given Fc prime equals 3000 psi and Fs equals 18,000 psi. After doing the calculation, we get N equals 9.289, K equals 0.411, J equals 0.863, and R equals 239. The ratio M in our design, which is the quotient of shorter span over the longer span, is 1.0, which at case 4 gives us a 0.058 moment coefficient for both short and long span. Proceed to flexure and slab thickness. With a total load of 142 pounds per foot, a short span of 20 feet, and a moment coefficient of 0.058, for both short and long span, we get negative moment at shorter span of 39,532.80 inch-pounds and a positive moment of 29,649.6 inch-pounds. At longer span, we get negative moment of 39,532.8 inch-pounds and positive moment of 29,649.6 inch-pounds. Choose the largest moment value to get the effective depth of 3.71 inches. Add 1.2 inch cover for 4.91 inches. Round up to 5 inches for total depth. Solve the area of steel on short direction given negative moment equals 39,532.8, positive moment equals 29,649.6, J equals 0.863, and D equals 3.8. The area of steel for negative moment is 0.67 square inch with a spacing of 3.5 inches, and the area of steel for positive moment is 0.5 square inch with a spacing of 4.5 inches. Since the short span is equal to the long span in our example, the area of steel and spacing in long direction is equal to the short direction. To test the short and long direction shear stress, we get the short direction shear force of 946.67 pounds and shear stress of 20.76 psi less than 60.25 psi concrete capacity, and the long direction shear force of 946.67 pounds with shear stress of 20.76 psi less than 60.25 psi concrete capacity. For bond stress, the summation of bar circumference per foot is 4.19. We get the short direction bond stress of 68.90 psi less than 500 psi concrete capacity, which same value for long direction. The design results to our problem are as follow. Fc prime equals 3000 psi. Fs equals 18,000 psi. Dimension at 20 feet by 20 feet. Thickness at 5 inches. Short direction bars of grade 33, half-inch diameter bar at 4.5 inches on center. Bend up alternate at S/4 plus 2 extra top bars at continuous edge plus 1 extra top bars at discontinuous edge. Long direction bars of grade 33, half-inch diameter bar at 4.5 inches on center. Bend up alternate at L/4 plus 2 extra top bars at continuous edge plus 1 extra top bars at discontinuous edge. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.